Today our objective is to be able to graph square root functions. We're also going to describe the domain and range of these functions. This is Chapter 10, Section 1, Day 1. Before we get started, we need to review what domain and range are. Domain are all of your x values, and range are all of your y values. On the first four questions, we're just going to describe the domain. So domain, again, are all of your x values. So on number 1, they're asking me, what numbers could x be? Well, I'm noticing x is under the radical sign, and when I take the square root of a number, that number has to be 0 or higher, so greater than or equal to 0, cannot be a negative number. So in this problem, x would have to be greater than or equal to 0. X is all real numbers greater than or equal to 0. On number 2, I'm trying to describe what values can x be when I describe the domain. If I look at the x, there's a negative x under the radical. That means negative x has to be greater than or equal to 0. Well, I just want to know what x can be, so I'm going to solve this inequality by dividing by a negative 1. When I divide by a negative, I have to flip my sign. So it's x is less than or equal to 0. X can be all real numbers less than or equal to 0. For example, x could be a negative 1. If I put a negative 1 in here and I take a negative times a negative 1, I will get a positive 1, and then I can take the square root of a positive 1. So basically on number 2, x can be any numbers 0 or less. It could be 0 or a negative number. On number 3, I'm trying to describe what values x could be. Under the radical, I have an x minus 5. That means x minus 5 has to be greater than or equal to 0. I want to describe what x can be, so I'm going to solve this inequality for x by adding 5 to both sides. So x can be any number greater than or equal to 5. All real numbers greater than or equal to 5. On number 4, x is under the radical, and under the radical it says negative x plus 8. So I know negative x plus 8 has to be greater than or equal to 0 for me to take the square root of that. So I'm going to solve this inequality for x to see what values x can be. First, I'm going to take away 8, and I'll get negative x is greater than or equal to negative 8. Then I'm going to divide both sides by a negative 1. When I divide by a negative, I have to flip my sign, so x is less than or equal to 8. So the domain would be all real numbers less than or equal to 8. On number 4, we're going to graph the function and describe the range. And I have two xy tables here because I want to show you two ways to find points on this graph. So the way to graph is to make an xy table. So I'm going to put numbers in for x and see what y could equal. My first table, I'm going to let x be 0, because 3 times 0 is 0. When I take the square root of 0, I get 0. So 1 point would be 0, 0. Then if I think of the numbers that I can take the square root of, my perfect square numbers that give me whole number answers, like 0, 1, 4, 9, 16, my perfect square numbers. If I try to get 1 under the radical so I can take the square root of 1, I can think of x as 1/3, because 1/3 times 3 is a 1. Then when I take the square root of 1, I get 1. If I try to make the number under the radical 4, I'm asking myself, well, what do I multiply by 3 to get a 4? That would be a 4/3. Because 3 times 4/3 would be 12/3, or 4. When I take the square root of 4, I get 2. If I try to make the number under the radical 9, so that when I take the square root of 9, I get a whole number 3, I would let x be 3. 3 times 3 is 9. The square root of 9 is 3. If you find this way complicated, you could do this. You could just go ahead and put in 0, 1, 2, and 3 for x, and then your y values won't always be whole numbers, but that's okay. So if I put 0 in for x, 3 times 0 is 0, square root of 0 is 0. If I put 1 in for x, 3 times 1 is 3. The square root of 3 is not a whole number. If I do the square root of 3 on the calculator and round to the tenths, I would get a 1.7. If I put 2 in for x, I would take 3 times 2, 6. Take the square root of 6 on a calculator, rounded to the nearest tenth would be 2.4. And if I put 3 in for x, 3 times 3 is 9, the square root of 9 would be 3. That would give me a whole number answer. Now, if I graph these points in either table, it's going to give me the same graph. So at first I'm going to graph 0, 0 for the first table, then 1/3 1 would be right 1/3 of the step, up 1. 4/3 is the same as 1 and 1/3, and then up to 2, and then 3, 3 would be a point, so right 3, up 3, and this would be, if I can draw a little better with my airliner here, the graph. Now, looking at the second table, 0, 0 is here. 1, 1.7 would be on my graph. 2, 2.4 would be about right there. And 3, 3 is here. So you can see it's the same graph. It really doesn't matter how you pick your points for your table, you're going to get the same graph. All right, moving on to number 5. Oh, go back to number 4. I need to describe the range. Remember, the range are all of your y values. So what numbers could your y be? So here's our y-axis. Y can be any number greater than or equal to 0. So the range is all real numbers greater than or equal to 0. All right, now we're on number 5. On number 5, we're going to graph y equals the square root of x plus 5. So I'm going to let x first be 0, because that's the lowest number x can be, because x can't be a negative number. If I put 0 in here, the square root of 0 is 0. 0 plus 5 would give me a y value of 5. I'm going to try 1 next. The square root of 1 is 1. 1 plus 5 would give me a y value of 6. I'm not going to do 2 or 3. I'm going to go right to 4 just because I like to graph whole numbers. I'm going to put 4 in here. The square root of 4 is 2. 2 plus 5 would give me a y value of 7. If I went on to my next perfect square number, which is 9, I could take the square root of 9 to get 3. 3 plus 5 would be 8. So here are some of the points on my graph. I'm going to graph 0, 5, so that means don't go left or right, go up to 5, 0, 5, then 1, 6, 4, 7, and my last point in my table is 9 up to 8. Okay, so my graph is going to look something like this. I'm having a little trouble graphing with this airliner. Okay, but you can see the y values, the range, would be any number greater than or equal to 5. So here's my y-axis. The range are my y values. The lowest number y could be is 5. Y could be any number greater than or equal to 5. All right, looking at number 6, I'm going to try to graph by making an xy table. I'm thinking of my perfect square numbers 0, 1, 4, 9, etc. So I'm thinking about, okay, what number could I put in for x so I get 0? So then when I take the square root of 0, I get 0. Well, x could be negative 2. If x is negative 2, negative 2 plus 2 would give me 0. The square root of 0 is 0. 0 minus 2 would give me a negative 2. Then I'm going to start thinking, well, how can I make this the square root of 1? Because 1's a perfect square number. What do I add to 2 to get a positive 1? Well, that would be a negative 1. If I let x be negative 1, negative 1 plus 2 is positive 1. The square root of positive 1 would be 1, but then I would have a 1 take away 2. That would be a negative 1. My next x value that I'm going to pick is what makes x plus 2 equal 4. Well, what do I add to 2 to get 4? That would be a 2. So I'm going to let x be 2, because 2 plus 2 would give me 4. Then I would have the square root of 4, which is 2, take away 2. That's going to give me a y value of 0. Then I'm going to think about, well, what can I put in for x to get 9 so I can take the square root of 9? Well, 7. 7 plus 2 is 9. So I would have the square root of 9, which is 3, take away 2. When I do 3 take away 2, I get 1. So here are some points on my graph. So if I graph these, negative 2 would be left 2, down 2. Negative 1 would be left 1, down 1. 2, 0 would be right 2, don't go up or down. And then 7, 1, I'm going to go right 7, up 1. And then I connect, and hopefully you do a better job of that, because I'm having trouble writing with my airliner today. I'm going to connect, and then I have my graph. So if I'm describing my range are my y values. Here's my y-axis. It's asking what numbers could y be. Well, the lowest number y could be would be negative 2. So the range would be all real numbers greater than or equal to negative 2, because this is going to keep on going forever and ever. So any number greater than or equal to negative 2 would be my range. Okay, number 7, I'm going to graph y equals negative the square root of x minus 3. So I'm going to go back and I'm going to think of my perfect square numbers, 0, 1, 4, 9, etc. All right, I'm thinking about what could I put in for x to make it 0. Well, if I put a 3 in for x, 3 take away 3 would be 0. So I'm going to start with x is 3. Because 3 take away 3 would be 0. The square root of 0 would be 0. And if I multiply by a negative, I just get 0. Then how could I make the x minus 3 equal 1? What do I take away 3 from to get 1? Well, that would be 4. 4 take away 3 is 1. The square root of 1 is 1. But then I multiply by a negative, I'll get negative 1. Then I'm going to ask myself, well, what can I put in for x to get 9? Well, 12 minus 3 is 9. So I'll put 12 in. 12 minus 3 is 9. The square root of 9 is 3. Then I multiply by a negative. I'm going to get negative 3. Today our objective is to be able to graph square root functions and describe the domain and range. As we get started, we need to remember the domain are all of your x values. What values can x be? Range are all your y values. On the first 4 problems, we're going to describe the domain of each function. So remember, the domain are all your x values. On number 1, they're asking me, what numbers could x equal? Well, I'm noticing I'm taking the square root of x. When I take the square root of a number, that number has to be 0 or higher. I cannot take the square root of a negative number. So x must be greater than or equal to 0. So the domain would be all real numbers greater than or equal to 0. On number 2, what values could x be? Well, under the radical, I have a negative x. So what's under the radical has to be greater than or equal to 0. So negative x has to be greater than or equal to 0. I need to solve this inequality for x, so I'm going to divide both sides by a negative 1. When I do that, I have to flip my inequality sign, so that makes it x is less than or equal to, and 0 divided by negative 1 is 0. So the domain is all numbers less than or equal to 0. On number 3, x minus 5 is under the radical. So I need to find out what values could x be. Well, x minus 5 has to be greater than or equal to 0, because when I take the square root of a number, it has to be a number greater than or equal to 0. It can't be negative. So what I'm going to do is take this inequality and solve it for x to find out what values could x be. That means by adding 5 to both sides, x has to be greater than or equal to 5. So x can be any number greater than or equal to 5, such as 6. I could put 6 in here. 6 minus 5 is 1. I can take the square root of 1 and get 1. If I chose a number less than 5, like 4, and I put 4 in there, 4 minus 5 will give me a negative 1. I could not take the square root of a negative 1. So that's why x, or the domain, has to be any number greater than or equal to 5. On the last one, I have negative x plus 8 under the radical. So that means negative x plus 8 has to be greater than or equal to 0. What's under the radical has to be a number greater than or equal to 0. I'm going to take this inequality and solve it for x. So first I'm going to subtract 8 from both sides to get negative x is greater than or equal to negative 8. Then I'm going to divide by a negative 1. When I do this, I'm going to have to flip my sign because I divided by a negative, and my answer would be x is less than or equal to 8. X can be any number less than or equal to 8. So if I put 8 in here, this would be a negative 8 plus 8. I'd get 0. Yes, I can take the square root of 0. If I put in 7, 7 is less than 8, I would get negative 7 plus 8. Negative 7 plus 8 would give me 1. I could take the square root of 1 and get 1. But if I chose a number higher than 8, like 9, I'd have a negative 9 plus 8, which would give me a negative 1. I cannot take the square root of a negative 1. So that's why the domain, or x, has to be less than or equal to 8. All right, on number 4, we're going to graph and describe the range. So I'm going to show you a couple of ways to graph by using a couple of different XY tables. So when I do the first one, I'm thinking of my perfect square numbers, 0, 1, 4, 9, etc. So if I put in 0 for x and take 3 times 0, 3 times 0 is 0, the square root of 0 would be 0. Y would be 0. If I try to make what's under the radical a 1, so I can take the square root of 1 and get 1, I'm thinking to myself, 3 times what gives me 1? Well, if I take 3 times 1/3, 3 times 1/3 would give me 1. The square root of 1 would be 1. If I try to make what's under the radical a 4, so I could take the square root of 4 and get 2, I'm asking myself, 3 times what gives me 4? Well, if I take 3 times 4/3, that would give me a 12/3, or 4. So if x is 4/3, when I take 3 times the 4/3, I get 4. The square root of 4 is 2. I could also ask myself, well, how could I get 9 for the number under the radical? Well, I could let x be 3, because 3 times 3 is 9. Then when I take the square root of 9, I get 3. If you don't like this way, you could do it another way. The only reason I do it this way is to try to get more whole numbers to graph. But I could also do this problem by just putting in a 0, 1, 2, or 3. It just means my y values won't always be whole numbers, but that's okay. So if I put in 0, 3 times 0 is 0, square root of 0 is 0. If I put in 1, 3 times 1 is 3. I'm going to have to take the square root of 3. I'm going to use my calculator and round to the tenths when I take the square root of 3. I'm going to get a 1.7. If I put in 2, 3 times 2 is 6. The square root of 6 rounded to the tenths would be 2.4. And if I put in 3, 3 times 3 is 9. The square root of 9 is 3. It doesn't matter which XY table you use, you're going to get the same graph. So if I graph the first one, the first points in the first XY table, my first point is 0, 0. 1/3, 1 would be right 1/3 up 1. 4/3 is the same as 1 1/3, so I'm going to go a little bit past the 1 1/3 up to 2, and then 3, 3. And my graph, when I connect my points, I need to do a little bit better job of connecting my points, is going to look something like this, okay? Now, if I take the points on the second table and graph them, you're going to see that it's on the same graph. Here's 0, 0, 1, 1.7. So if I go right 1, up 1.7 would be here. 2, 2.4 would be about here. And 3, 3 is here. So it really is the same graph. Okay, they are points on the same graph. When I describe the range are all of your y values. So here's my y-axis. What numbers can y be? Well, the lowest number y could be is 0. And then they just keep going up from there. So the range is all real numbers greater than or equal to 0. All right, on number 5, I'm graphing y equals the square root of x plus 5. So I'm just going to put in 0, then 1. 1's a perfect square number. I'm going to skip 2 and 3 because they're decimals, and I'm going to go right to 4 and 9. I'm just going to use perfect square numbers. You could go 0, 1, 2, 3. It's just you'll get decimals for your y values, and that's fine. It'll be the same graph. So if I put in 0, the square root of 0 is 0, plus 5 would give me 5. If I put in 1, the square root of 1 is 1, 1 plus 5 is 6. When I place 4 in for x, the square root of 4 is 2, 2 plus 5 is 7. When I put 9 in for x, I'll have the square root of 9, which is 3, 3 plus 5 is 8. So those are points on my graph. So if I graph 0, 5, that means don't go left or right, go up 5. 1, 6 is right 1, up 6. 4, 7 would be right 4, up 7. And 9, 8 would be right 9, up 8. Okay, so if I try to connect these points, and put an arrow at the end because it's going to keep on going, this is what my graph would look like. So when I describe the range, remember the range are all your y values. Here's my y-axis. What numbers can y equal? Well, the lowest number is 5, and then it goes up. So the range would be all real numbers greater than or equal to 5. All right, number 6. We're going to graph and describe the range. So I notice I have an x plus 2 under the radical. And the way I'm going to make my xy table is I'm going to think about 0, 1, 4, 9, my perfect square numbers. So first I'm thinking, how can I make what's under the radical 0? What can I add to 2 here to get 0? What could x be? Well, x could be -2, because if I add -2 and +2, I get 0. Then I would have the square root of 0, which is 0, minus 2. 0 minus 2, that would give me a -2. Then I'm going to think about, well, what could I put under the radical for x so that I get a 1 when I have an x plus 2? So I'm asking myself, what do I add to 2 to get 1? Well, that would be -1. If I put -1 in for x here, -1 plus 2 would be a +1. The square root of +1 is 1. Then I would have a 1 minus 2. A 1 minus 2 would be -1. Then I'm going to try to make what's under the radical of 4, because the square root of 4 is 2. Okay, so it doesn't mean my y value is 2, it just means I'll get 2 when I take the square root of it. So let's see, if I put in a 2 there, 2 plus 2 would be 4. The square root of 4 would be 2. I would have a 2 minus 2, because I would have to take away 2 after I took the square root. So that would be a 0. Next, what I'm going to do is figure out, well, what can I put in for x to get 9? Because I could take the square root of 9 and get 3. So what do I add to 2 to get 9? That would be 7. 7 plus 2 is 9. Then I would have the square root of 3, the square root of 9, because I'm going to put 7 here. 7 plus 2 is 9. The square root of 9 minus 2. Square root of 9 is 3. 3 take away 2 would be 1. So I would get a y value of 1 if I place 7 in for x. Now I'm going to graph these points. So left 2 down 2. This is negative 2, 2. Negative 1, 1 would be left 1, down 1. 2, 0, right 2, don't go up or down. And 7, 1 would be right 7, up 1. And then I'm going to connect and put an arrow at the end. And this would be my graph. Now I'm describing the range. The range are all my y values. So what's the lowest y value? It's a negative 2. So my range would be all real numbers greater than or equal to negative 2. My y values can be any number negative 2 or higher. Okay, number 7. We're going to graph y equals negative the square root of x minus 3. So once again, I'm going to try to do it where I can make what's under the radical 0, then 1, then 4, then 9, just because I want to have whole numbers. So if I put, let's see, what could I put in for x so I get 0 here? What do I take 3 away from to get 0? That would be 3. X would be 3. 3 take away 3 is 0. The square root of 0 is 0. When I multiply by a negative, I'll still get 0. Then I'm thinking, well, what could I plug in for x so that what's under the radical gives me a 1? X could be 4. 4 take away 3 is 1. So I'm going to let x be 4. 4 take away 3 is 1. The square root of 1 is 1. But then I have to multiply by a negative to give me negative 1. Next, I'm going to take the square root of 4. I want to make what's under the radical here 4 so I could take the square root of 4 and get 2. So I'm asking myself, what do I subtract 3 from to get a 4? That would be a 7. So if x is 7, I would have 7 minus 3, which is 4. The square root of 4 is 2. When I multiply by a negative, I get negative 2. Next, I can let x be, let's see, I'm trying to make 9. So what do I subtract 3 from to get a 9? Well, that would be a 12. So I'd have negative square root of 12 minus 3. Because 12 minus 3 would be 9. So if I put 12 in for x, I got 12 minus 3, 9. The square root of 9 is 3, but I multiply by a negative, I'd get negative 3. This one's going to be off my graph a little bit, so I'll just graph the other 3 points. So if I graph 3, 0, I go right 3, don't go up or down, here's 3, 0. Graph 4, 1, right 4, down 1, whoops, right 4, down 1. And then if I graph 7, negative 2, I'm going to go right 7, down 2, okay? And then I connect, and you think about, well, 12, negative 3, here's 10, 11, 12, would be about right here. It's off my graph. And then I connect and put an arrow at the end. Okay, so now my function is graphed. I need to describe the range. The range are all my y values. What numbers could y be? Well, I'm looking at my y values here on my y-axis. The highest y value is 0. And then from there, they go down. So y would be all real numbers less than or equal to 0. Y could be any number less than or equal to 0. So let's review our objective. Our objective today was to be able to graph square root functions. We also described the domain and range. Today's assignment is page 548, numbers 6 through 26 even. You're going to do these on the Big Ideas website.